is going to right. Okay, good. So we'll have a two-part. We're going to have a two-part recording. Okay, so let's quickly go on to what we were dealing with here. Question. Next question. Right. Good. Right. So the next question was a fairly straightforward convolution question. This was an example of something that would have been done in ECNG3025, and as I mentioned now, because we can do it fairly easily using discrete time, that you could try the same convolution manually, use it by sampling. So I told you all to take the sample signal, take at least 5 samples, and perform the convolution. One little thing about this though is that, and you have to be aware of this when you're sampling. If I were to take the samples, 5 samples of HT, we know that the samples are we're going to take 5 ones, right? So you take it like every half. Let's say these are seconds, so you take it every half second, right? So it'll be 5 ones, 1, 1, 1, 1, 1. And here will be 0, 0.5, 1, 0.5, and 0. What you always have to be careful with is what is the actual point at which I took the sample. Do I take the sample immediately after the 0 point, or at 0, or just before? Same thing for all the samples. So for instance, if I said HT, I was taking the value just immediately before, then the values that I would have gotten here would have been 0, 1, 1, 1, 1, right? So it would have been 0, and the 5 ones, everything would have been delayed by 1 period. All right, same thing here. It would have been, well, this one would not make a difference, but the first sample, if it's just before here, would have been 0, just before 0.5, well, 0.5, and so on. The main issue would be when you're sampling things like a suddenly changing signal, what is the value that you're going to use, right? And that is important because in our real-time situation, if the signal changes faster than your sampling ability, then you could actually be sampling the wrong things. Okay, so if this, like how this is changing suddenly from 0 to 1, then at the point when I take a sample here, depending on where I'm sampling, the value could either be 0 or 1. Okay, that was just to show in some of the what shall I say, the nuances when you're doing this in the real world. But if it took the sample here, you have 5 ones and you have 0, 1, 0, 0.5, 1.5, 0. You put that into the convolution table and you work out the answer, right? And you could get the answer and you will get a plot. At least if you have 5 samples of each of them, right, the actual sample, the actual answer is going to be, as we said, 1 less than the 5 plus 5. That was all in the discussion that we had. So you're going to have 9 samples in all for your answer. All right? Everybody okay with that? Right, question 5. How many people had a crack at question 5? Anybody had a look at question 5? You didn't get to 5. What about other people? But that one is one that requires a little bit of thinking. All right, and let me show you how to approach it. Where's the whiteboard? Right, there we go. So I have a sequence of values, and the sequence of values Right, let me go to another little screen here. I have a sequence of values, and the sequence of values in this case is running from -5 all the way to +14, right? So how many samples do I have here? N equal to what? N is equal to what? 20, right? So I have 20 samples, right? So N is, if you want, N is 20, right? So if I flip this around, let me see if I can get a different color here. If I flip this around, so this is X N. When I am finding the convolution, remember I have to flip it and slide it around, right? So it's going to run from +5 to -14, right? How many samples, right? So you're running from +5 to -14 there. How many samples is the overlap zone? The overlap zone is here to here. How many samples is that? How many samples in that overlap? 11, right? Because remember, we're running from -5 to +5. Always remember there's a value at 0. Eh? So -5 to +5 are 11 samples. So if I have to start the convolution now, I have to shift the red sequence all the way back to here, right? So to do that, if the overlap is 11 samples, I have to shift this back 10 samples to get the first overlap, where this value here and this value here will be overlapping. So in other words, the index of the first value is going to be -10, right? And then we saw right. We saw, I don't know how long this internet is going to hold out, so let me just quickly say, we saw that if I have two sequences and the sequences are 20 samples long, then the overall convolution is going to be 20 plus 20 minus 1, which is 39 values. Yeah? So in other words, the first value is at -10, and we have 39 values in the whole convolution. So the last index is going to be y something. In this case, it's 20, so you can work it out because you have to correct for the 0 value. So if I run from -10 to +28, that is my my total convolution length. So the first index is going to be -10. The last index is going to be y28. Together, you have your 39 samples. And if not, you could figure it out by here. If I start here, right? If I start here, let me just use a slightly different color here. My first value is at -10. Where am I? Right? Where's my good? -10. I'm going to have to shift to get the whole overlap. Right? I'm going to have to shift 19 this way for first full overlap, and then another 19 this way until this value and this value overlap with each other, and then the convolution ends. Right? So 19 and 19 are 38 values plus the first one that you had, which is the 39th. So that's why you could also look at it that way, right? And if I started at -10 and I went 39 up the road, then the last value is going to be Y28, okay? So run that through and look at the explanation that I have. Try it and see. If it doesn't make sense, then we can talk Wednesday. All right. And let me see the other questions that we had here. Okay, so this was fairly easy. And question 7, right? So question 7, again, MATLAB has a CONV function. So you could get these values manually and put them into the convolution table and see what answers you get. And then, sorry, I'm not sharing. You don't see me. My mistake. Where are we? Right. Good. Look at this one. So you can generate these values. You can do it manually. MATLAB has a CONV function. So this was, again, to generate these values. So it's running from n equal -1 to 6 here, right? This one will be running from -3 to +4, right? So you don't have too many values. You could put the two sets of values into a convolution table and get some answers. And then once you have the values there, let MATLAB do the convol function for you. So do it manually and do it with MATLAB. This is n equal something to something. Run the convol function and see if the answer turns out to be the same. It is supposed to. All right. So a fairly straightforward problem set, but to get us thinking on how we manipulate signals and how we shift them around a little bit. Okay, so Wednesday we will continue our discussion on the fast Fourier transform, where we ended last time with the actual butterfly operation. This time we're going to start from the output and work it back towards the input. So we'll actually see what is the process that is involved. And then we'll do some manual FFTs in class to make sure that we get the handle. And if you have any questions on the problem set, then of course, you could take it up with me in class on Wednesday, please go. All right. So everybody all right? I hope this, there was a bit of an interruption here. So I'll put up the recordings. I'm sorting all that. So by this afternoon, all the recordings, including today, there will be a 2-part recording for today. And I'll see you all on Wednesday morning, please God. Hopefully we have power and work. Power went last week, Thursday. I think it was in the middle of a meeting as well too. So this is a little bit strange. Okay. All right. So that's, if there are no questions, let me stop it here so I could save some